Wait. Oh yeah, now we're recording. All right. All right, so we're in chapter 3. All right. And we've already discussed the lecture slides. So just to rehash what we went over, right? We talked about vectors, and we talked about vectors having components, right? Vectors have x and y component. Okay, that's in two-dimensional space. But if we were in three-dimensional space, then they would have 3 components, and those components would be x, y, and z. All right. So, but since we're only in two-dimensional space, we're only going to deal with the x and the y. Okay. So, and I'll go and I'm going to post a, the narrated lecture slides where I talk about problem solving steps and all of that. And I go back over that stuff. Probably do that this weekend. All right. But now we are going to solve some problems here. Ouch. The homecoming week was next week, right?
Yes.
Okay, so folks say they're gonna take a week off or take a week early, huh? Well, when we have this kind of lack of participation, I like to do little things, So we're gonna see what happens from here. What time is it? 11:58. Is that right? 54. Okay, we got a little time. Get back to what I was saying. Yeah, I'm gonna post the narrated lecture slides so you can go back through that, right? A lot of junk here. All right. There we go. We got some takers. They falling in slowly but surely. All right. So, let's get into like some basic stuff about vectors, right? So before we do anything applied with vectors, let's just actually do some vector math, okay? And so, I didn't briefly, but we discussed this in the lecture slides, okay? On how you do vector mathematics. And so we're just gonna take an example. There's an example in the book that I like to start off with, every year, just to cut right through the chase and get straight to it, okay? This is on page 69 in my book. Okay? So we have a vector here, and I wish I had one more color chalk, but I don't, or 2 more colors, but it's fine. We'll just use these. And this is what a vector looks like, right? This is what a vector looks like. This is a vector A. This is a vector B. This is a vector C. Right? A vector has two things. What are they? It has two components, but it also has what? Two major things. One without the other, it doesn't make sense. When I describe a vector, what do I need to say? Huh? Not coordinates. Direction, and M word is the other one. M starts with the M. Magnitude. Yes. Magnitude and direction. So A has a magnitude of 44 units. And it points in the what? Northeast. Right? Okay. B has a magnitude of 26.5 units. Okay. And C has a magnitude of 31.0 units. Okay? So, as I mentioned to you before, in physics, we indicate directions with angles. Okay? So this is what? 0 degrees right here, right? And I go this way, this is what? Huh? 90, 180, 270, 360. Okay? So the vector A points in a direction, right, which is 28 degrees with respect to the positive x-axis. Tell me when you lose me. The vector A points in the direction which is 28 degrees with respect to the positive x-axis. Everybody following what I said? Okay. This is 28 degrees. Okay. All right. So B points in a direction what? 56 degrees. Right? And I should have said north here, but I just assumed, well, I shouldn't assume, but I should have said it points in a direction that is 28 degrees north, right? With respect to the positive x-axis, okay? So what would happen here is we would say what? That vector B points in the direction north, right? 56 degrees with respect to the negative x-axis. Everybody following that? Please don't tell me when we get 2 weeks into this that you don't know what I'm talking about when I say with respect to the positive x-axis, or with respect to the negative x-axis, or the negative y-axis. Okay? This is the negative x-axis, positive x-axis, positive y-axis, negative y-axis. Okay? Just a little friendly reminder. Okay? Just to remind us about our Cartesian coordinate system, right? Cartesian coordinate system. Okay? And so, vector C, right, it's going to point 90, 180, 270, right? 200 points in the direction, right, south, 270 degrees with respect to the what? Not the negative. I started from here. What is this? That's the positive. Didn't start from the negative. I told you this is the positive right here. Don't guess. Don't guess. We're not in the game. We ain't not in guessing game here, y'all. All right? We don't guess nothing. We don't guess nothing. If we're not sure, then we got to say, well, what is the procedure for figuring it out? Because everything has a procedure. Everything. Somehow when we get to college sometimes, y'all, and I know because I used to be a student just like y'all, somehow we think that it's just some kind of trick or something. No, everything has a way of doing it, and it has to be explained. Somebody can't explain to you how it's done, then they don't know what they're talking about. And you can tell them I said it. And that goes for anybody. If they can't explain it to you in a way that you understand it, they don't know it. That's the bottom line. Okay? So, the C vector points south, in the direction south, right? 270 degrees with respect to the positive x-axis. This is where we start. When we start counting, right? And we go that way. And we go this way. And we go that way. And we back to where we started. 360 degrees. Okay? So now we're going to add vector A plus vector B plus vector C. Okay? Okay, so I told you that every vector has a what? X and Y. I'm listening. X and Y. Volume.
No, value.
Components. What are components?
Something that goes with.
Something that makes up something else. That's a component. Every vector has two components, X and a Y. That's what we started the conversation off with today. So, vector A has X, Y component, right? So X, what are components? Components tell us how much or how far does the vector go in a specific direction? Yes. Okay? So, how do we identify the x and y component?
Direction and magnitude.
Right? So for vector A, where is the x component for vector A?
Would that be?
It'd be right here, right? Because it tells me from here, there, tells me what? How far the vector A goes in the, Yes, in the x direction. Speak up, y'all. I can't hear you. Y'all gotta speak up. Okay? If we continue to answer like that, then we never build confidence. Never ever. You gotta speak up and say it, and then if I say it, and if I say no, like with the same force, right? That's because I'm trying to show you how to be confident. Because that's what's gonna make you confident. When you get somebody who's just as confident that tells you no, because that's what people used to do to me. And then I made myself get to a level where people couldn't say, no, that's wrong. People just couldn't say nothing no more. Right? And that's where y'all trying to get. Okay? So x and y component. So this right here, this tells me how far A goes in the x direction. Right? So where's the y component of A? What did I just say? A component tells me how far the vector goes in a specific direction. So show me where the y component of the vector A.
Just go down from where x is or up.
Go so from here and do what?
And go up because you're trying to.
Right? So it's telling us how far the vector A goes in the y direction. So that's the y component of A, and we can denote that with, right? This is 28 degrees. We can denote this as what? A sub y. And we can denote this as what? A sub x. And remember, what did I tell you about every vector? Every vector has what?
Two components.
Oh man, I was about to say, man, y'all still ain't get this, man. How many times do I have to say it? Over and over and over and over.
I'm trying to keep up.
So A, right? So if I say A, right? A sub x plus what? A sub y. Those two together make up the vector A. And that's just based off of what? Pythagorean theorem. Right? Because this is what? What does it say? A squared equals what? B squared plus C squared. Right? Where this would be my what? Hypotenuse. And then I have what? AX squared plus AY squared is equal to A squared, right? A squared equals what? A sub x squared plus A sub y squared. Pythagorean theorem. Right? So, right? So that's how they're related. But we know that there's some more math involved, right? And that's related to Pythagoras, or, well, I'm I mean, I guess it's related to Pythagorean theorem too, but more trigonometry. And that's what? Sine, cosine, and tangent, right? So I'm just gonna draw vector A over here again in this little fake Cartesian coordinate system over here. A, right? And we said that's what? 28 degrees, right? And we said this is a sub x, and this is a sub y, right? And take that 28 from there, put it right here, all right. 28 degrees, right? And so, and this is vector A, right? And I know that that opposite of my angle, right? If this is theta, right? Theta, right? Then I know that opposite of theta, right? So sine, right? So sine of theta is equal to what? AY over what? Over the vector A, right? And so cosine theta is what? AX over A. And tangent of theta is huh? AY over AX. So then I know in order to find my components, right? I do a little math right here, right? I know if I rearrange this equation, right? And I'm just gonna write it above and then erase it, right? So AY is equal to what? A times sine theta. Right? In this case, is AY always the sine of theta? No, not always. Depends on the angle. And we'll do some where that changes. Okay? AX is what then? That's it? A times cosine theta. Right? So, we don't need the last one, right? Because we just need to find X and Y components. So now we can plug those in, right? And we get what? AY is equal to what? What is A? 44. Sine 28. Say what?
Are we looking for the other side?
No, we're looking, we already rearranged the equation for the, what is this? See, that's what we gotta understand. See, we jump into math and we don't even know what things represent. So it's useless. Doing math is useless if you don't know what things represent. It's useless. It is an exercise in futility. What is this? Of what? Yes, we have to be complete, y'all. It is the y component of vector A. That's what we're looking for here, right? X and y components. So, here, I just did what? I substituted 44 for A and 28 for theta. And whatever that result is, gives me my what? Y component of vector A. That's it. There's no more solving after that for the y component. Okay? So what is it?
I got 20.57. I mean, 56. Wait, 20.66.
20.66. Somebody else got it?
I got 11.92.
So somebody's right, somebody's wrong.
It's supposed to be in degrees, right? Not
Yes, the calculator must be in degrees.
20.67.
20.67. Got your calculator in degrees? Ma'am?
I'm changing it.
So the y component is 20.67 units. Right? Now for the x component. What is it? (44) cosine 28 degrees. And what's that? 38.85 units. So I have 20.67 and 38.85. Right? So now we look at vector B. Right? Every vector has what? Two components. X and Y component. So I'm going to draw an imaginary coordinate system in the, what quadrant is that? Second quadrant, right? What the hell? Leave. That's B. 26.5 units, right? And 56 degrees with respect to the negative x-axis, right? North of the negative x-axis, right? So if this is 56 degrees, then this must be what? From here to here. What's that?
34.
34?
Wait, oh, well, 90 plus 34, right?
Yes. Which is?
124.
124. Right? So this is actually what? We could write it as 124 degrees, or we can say what? With respect to the 56 degrees with respect to the negative x-axis. Or if we say what? 124 degrees with respect to the positive x-axis. This is the positive.
Oh, there you go.
This is the negative. Positive points right. Negative points left. Positive up. Negative down. I need y'all to commit that to memory, y'all. Don't be confused by that. Okay? This is gonna make better sense to you once we do some more geometry and blah blah blah. You're gonna be like, oh, okay, this is just this backwards. Yeah. Just this, if you flip it in the other direction, it's gonna be this. Yeah. That's exactly. Right? Because they all fit into what? 360 degrees. So if we chop that in half, we have 180. Right? And so from here to here has to fit in 180 degrees. Every time. No exceptions. Okay? So now let's get back to the components, right? So what are the components? How do we identify the components? Graphically, drawing on the graph. How do I identify my x component of b? Going across at the top, right? That's what? B of x. And this is what? B of y. Right? And so B of x, right? So now we have what? We have, let's say sine. So now we have what? Sine. So this is theta, right? So sine of this angle is what? Opposite over adjacent, right? So B of y, sine of theta is B of y over B of b, right? The vector, b. Okay? And adjacent, cosine, same angle is the adjacent side, which is the x, right? B of x over b, right? So when we rearrange these like we just did, right? We get what? B of y is equal to what? B sine theta. Right? Same thing for cosine, right? Cosine is what? B of x is what? B cosine theta. Alright? So now we can plug those numbers in, right? By equals, right? B, which is what? 26.5 sine of 56 theta. 56 degrees, sorry. That's B of y, right? And B of x is going to give us what? 26.5 cosine 56 degrees. All right? What's the numbers?
First one, I got 21.97.
Which one?
B of y.
You got what?
21.97.
21.97 units. All right. And what else?
The other one I got 14.82.
14.82 units. All right. All right? So what we need to recognize here is that, right, the fact that we took everything with respect to the negative x-axis, right, is going to make the x component negative. So the x component, which is here, right, is what? Negative 14.82. And the y component is what? 21.97. And that's because if we do it with respect, if we do 124, if we take that angle, then we're going to get the correct signs on it. But it's easier, in my opinion. I'm saying it's up to you, however you want to do it, right? But it's all geometry, right? 56 is just what? 180 minus 124. It's up to you how you want to do it. Or you can just remember by looking at the graph that what? It's pointing to the left. So it should be negative. If it was pointing down, then the y would be negative. That's why drawing these diagrams is important. Okay? All right, so now we got components for B. We got components for A, components for B. Now let's do C, right? Component C. Component C is quick. C is quick, right? So C is, so let's just draw. Y'all got all of this, hopefully, right? Let's get this. Now we in vector C. So now we are resolving. So I hope y'all are picking up on the words that I use, right? Because that's a huge problem too, right? When people don't know what I mean by certain words that I use, okay? This is the language, right? So when what we did is resolved the vector into its components. We resolved the vector into its components, at least A and B. Now we're doing C. We resolved A and B already. Now we're going to resolve C. Right? So I can redraw C, vector C, over here in a fake Cartesian coordinate system, or imaginary Cartesian coordinate system, right? The third quadrant, right? Or, well, not necessarily in the third quadrant, but it's actually on the y-axis, right? So let me just do this. I don't know, where's my white? I'll put it in my pocket. Yeah. All right. So let me just do that. Okay. Vector C. All right. So remember what we said the components are. What are they? Repeat to me what they are in words. What are components? They tell us what? How far?
How far the vector is going in the
Okay. So what's the C component? What's the C component? What's the X component of vector C? Huh? Yes. Why? Exactly. It only points down. So the X component of vector C is 0. Good. So then, by that same token, what's the Y component? Yes, 31, but what? Negative 31, because it points down. Good. That was good. Okay? So now we got components for A, B, and C. And so when I add A, B, plus C, what I do is I add individual components. So A vector. So this is an entire vector, right? This is an entire vector. It's composed of what? A plus B plus C, right? And A has what? A x plus a y. B has bx plus by. C has cx plus cy. Right? So, by that same token, then what? Then A plus B plus C has what? X, or I should do this. This is equal to what? A x plus B x plus Cx. All of that is what? The x component. So when I added up the individual x components for each vector, it gave me one new x component. So the same thing, I'm going to do the same thing with what? With what? The y's. I'm going to add up each one. That's going to give me my new y component for that new vector. Okay? So then, by the example we just used, A, what was the A component? 20.66, right? So let's write it up here. So it'll be what? 20.6, let's say 20.67. What was the B component? Negative 14.82 plus what? 0, right? That's the x component. And then we're going to get our what? Y component. What was y for A? 38.8 what? 5 plus B. Huh?
The AX and AY are flipped.
So AX component. What is the AX component?
38.85.
Okay. And this one is 20.67?
Yeah.
Okay. 20.67. So folks, so this is what I'm telling you. See, this is why it's important that we have to be organized. Because there's gonna be a lot of things going on. We gotta stay organized because we're gonna start mixing up things. And we're gonna confuse ourselves. It's physics. Physics can easily do that. Physics has a tendency to do that. So what's the y component of B? 21.97. And then the y component of C. Negative 13?
31.
Negative 31, yeah. All right, and then all of those together is gonna give me my new y component. So what is this? 38.85 minus 14.82? 24.03. So my resultant vector, this is called the resultant vector. When I add A plus B plus C, it gives me a resultant vector. It has x component of 24 point what? 03. That's in the x direction, right? Plus, what is this? 11 or something, negative 11? 11 point what?
6, 4.
11.64. So it's gonna give me what? We can either keep it as plus minus 11.64 y, or we can just change the plus to what? Negative. So my new vector is gonna be what? 24.03x minus 11.64 y.
Why is it minus?
Yeah, I was gonna ask, why is it negative?
Because you 20.67 plus 21.97, right? I plus this 31, negative 31,
So isn't that subtracting 31?
Right?
plus a negative 31.
It'll still be positive. Because you have 40 something.
Oh, okay. Yeah. My bad. That's my mistake. Yeah. Okay. Yeah. My bad. Good. So then what's the direction of the new vector? The direction, right, is inverse. That's finding out theta. That's what? Inverse tangent of the y component over the x component. So that's how I determine in which direction. Because that just tells me what? Huh? The vector tells me what?
How far?
The magnitude.
Yeah.
How far the vector is going. Doesn't tell me what direction. That's the other component. Remember I said you can't use one without the other is useless. So how do we determine the direction of the vector? Inverse tangent y over x. So then how do we do that? So it's gonna be what? Inverse tangent of what? 11.64 over 24.03. That's gonna give me my answer in degrees. Is it 20?
25.85.
25.85? Okay.
Can we just round that to the whole number?
No. Just write what's on the calculator, whatever the calculator be. All right, so that was one. That was one, y'all. One part, like A. You know, I got like A, B, C, D. That was A. A plus B plus C. Then I'll give you probably what? A minus B plus C. And then C minus A minus B. So I'll just change them all up. We'll just play little games with that and put and so you can understand, like I said, that this is about organization. That's what this really is about. It's about organization and being able to keep track and be complete with things that we do. Right? It's really about process. This is really about process. Like the math is very minimal, right? All the math is done by the calculator, okay? You just have to keep track of all these numbers and what they mean and where they fit, okay? But we're gonna get quite a bit of practice on that, okay? Say it again.
Monday.
Well, yeah, Monday, the next day, and the following day probably. Right, before we move to chapter 4. But we're gonna be in chapter 4 before you know it. Cause like I said, I wanna complete, we only have like about a month left. About a month, 2 months, or a month and a half left. So I wanna get to at least chapter 6. Right? Ideally you do you cover 10 chapters, but that's wishful. That's wishful. Nobody does that anywhere. It's not possible. Unless you got graduate students and you got TAs and all kind of people helping you and people can go to their office hours for help and all that. You can do it then. But no, I have to go at a certain pace because I can't just sit around all the time and field questions. Because I got a million other things to do. Right? So I have to go at a certain pace. That's why I do. That's why I go at the pace I go. Because I can't be as available to people because it's just not a lot of me around. Right? So that's why we go at a certain pace. But if we can get to 6 or 7, then that's solid, I think. All right? So we're going to pick it up over the next several weeks. All right? But we're going to get plenty of practice with this, and then we're going to start applying it to real world applications. Yes?
Is our grade gonna be for midterm?
Oh, yes. Yes. Sure. Yep. Any other questions? Concerns? Comments? All right. Do we have a roll going around today? Let me get a roll going. Since it's Friday. So I guess folks, don't y'all get like next Friday they're gonna be having like events and stuff, right? Okay. Yeah. Excuse me. Yes. Did you see? Excuse me. Oh, I don't know if it's gonna be in Moodle. It's probably be on Banner though. Definitely on Banner. Not on Moodle though. I just thought about that. I don't. Oh yeah.
Just the midterms, right?
Yeah, I don't use Canvas like that.
I'm saying like the union